All right, students. So I have a question. Do you think that the square root of 9 plus 16 is equal to the square root of 9 plus the square root of 16? So first you can ask yourself algebraically, are we allowed to do that? Are we allowed to take the square root of each part? And if you're not sure, you can make up some numbers and see if they're equal or not. So 9 plus 16, if we combine those first, we get 25, and we know the square root of 25 is 5. On the right side, the square root of 9 is 3, and the square root of 16 is 4, which gives us 7. Those aren't equal, so we know that we're not allowed to do this actually. Similarly, you can look at something like if you have two numbers that are being squared, would be a good example. I'll do 2 plus 3 here squared. And is that the same thing as 2 squared plus 3 squared? Well, 2 plus 3 is 5, and 5 squared is 25. On the right-hand side, we have 4 and 9, which add together to 13. So clearly, these things are not equal to each other. We know that if we want to square 2 plus 3, we would have to actually expand it. 2 plus 3 times 2 plus 3. No, of course, I mean, we know it's 25, but so we'd actually have to FOIL in this case if these weren't like terms that we could just combine. So similarly, there probably are some examples we can think of where this would be true, that the left and the right would be equal. But this is also not something that's true for sine. So the sine of the angle A plus angle B is not just equal to the sine of A plus the sine of B. It'd be great if it were, but it is not. So what is it equal to? Well, let's look at our notes. We need sum and difference identities to find out what it's equal to. So in our notes down here on the bottom right, we can see that it's pointed out that these two things are not equal. That's just what I explained above. And in fact, in the first exercise here, you'll be able to find the sine of u plus v. And then you'll also be able to find the sine of u plus the sine of v. And you'll see that they're not the same as each other. So they are not equal. But what is the sine of u plus v or a plus b or any two different angles? Well, we have these formulas. And I'd like to point out some things about them. I've added a lot of color here that you don't have to add, but these ones are really good to memorize. In my general pre-calculus class, I'm not going to require that you memorize them, but I am going to give you extra credit if you do. You are required to memorize the Pythagorean identities. So the sine squared plus cosine squared is 1, and then the two others that follow from that, all three of them you need to memorize for test points. But you do not have to memorize the sum and difference identities. If you do, though, you will get extra credit test points. So that can help improve your test grade. So here we go. To find the sine of angle A plus angle B, what you do is you actually have to add these two different terms. The first term is going to be the sine of A times the cosine of B. You're going to calculate that, multiply it together. That's going to be one term. And then you're going to add to that the cosine of A times the sine of B. All right. Now, if you want to find the sine of the difference, not just the sum when you're adding, but the difference of two angles, then the formula for that is very similar here, but you'll notice there's a minus sign instead of a plus. Otherwise, it's the same as above. Now, let's look at some things about these two formulas, or these four formulas, or the six formulas actually, but I'm focusing on the sinusoids first. So when we're trying to find the sine of two angles, what you'll notice is the sine of this term here, here stays the same. So if we're finding the sine of A plus B, then the sine here stays the same. It's still plus. So I like to think of this as the sign staying the same for the sines. Likewise, if this is a minus for the sines, this is also a minus. The sign stays the same. What's different, though, about sine is that sine and cosine are grouped together here, and then cosine and sine are grouped together here, so that's different. In contrast, what is the same about cosine? Well, the sign is not the same. Plus changes to minus. But what is the same is that the cosines are together and the sines are together. So that's something that's the same. What also is the same for all of these is A is what we call the first angle, and B is what we call the second angle. So we're always going to have the first angle first and the second angle second in our first term, and then we'll have either adding or subtracting, and then we'll have the first angle first and the second angle second. So that will stay the same. So let's maybe look at an example of how we can kind of combine these, or how I can think of it. Down here, if we want to find the sine of u plus v, well, I'm going to do this without even looking above, okay? I'm first going to find, first of all, it's a sine, so I know the sign will stay the same. So now I know I'm going to have a giant plus sign here. I also know I'm going to start with sine. And since the sign is the same, I know that these are not the same. I'm going to have a sine and a cosine here. And then I will have a cosine and a sine next. Cool. So the last thing is I just need to plug in my u's and v's. So if the first letter is u, then I'm going to have the first letter here be u and the first letter here be u. And the second letter is v. So I'm going to have v and v. And actually, for these examples, we can go ahead and plug in what they are, because we know that v is pi over 2, and we know that u is pi. So we can go ahead and actually plug those in and calculate. It's pretty cool, though, because, yeah, I was able to figure out that formula just by memorizing it. Now, another way we could find the sine of u plus v is actually just think, wait a minute, the sine of u, which is pi, plus v, which is pi over 2, that's just 3 pi over 2. And we totally know what the sine of 3 pi over 2 is. 3 pi over 2 is down here on the unit circle, and the height of that is -1. So I know the answer should be -1. Now, most of the time that we're using this sum and difference formula here, we're not going to know the sine of these two angles we're not going to know the sine of their sum, so we're going to have to break it apart. An example of that would be below. So I don't know what the cosine of 15 degrees is. It's not one of the special angles that we've memorized, so we don't know how to find what it is. We can't do this method on the right here where we just add the two angles together and then find the trig function of it. It's not going to work for us. So instead, what we're going to do is break up. We don't know what the cosine of 15 degrees is, but we do know that 45 and 30 degrees are both very special angles that we do know the cosine and sine of. So that was my hint down here. I guess I just gave away the answer. So we know that 15 is equal to 45 minus 30. And since we can't automatically figure out what the cosine of 15 is because we don't know it, we can find out what the cosine of 45 minus 30 degrees is. So let's go ahead and think about that. This is cosine. So cosine, this minus is not going to stay the same. It's going to change. But what is going to stay the same? Well, it's going to start with cosine because cosine starts with cosine. What is going to stay the same is that the cosines are going to stay together. And then the sines will come after that. Great. Now all I have to do is plug in my 45 degrees as the first, because the first stays first. And then I'll plug in my 30 degrees. This is not -30. Minus was part of the sign that changed. So 30 degrees here and here. Now the cool thing is that we know how to solve this. So go ahead and give it a pause and try to solve it on your own. You should definitely be able to do this yourself. All right, I know that this is going to be a medium width here, so this is going to be root 2 over 2. This one is going to be a big width, so that's going to be root 3 over 2, and we're multiplying them together. I know that sine of 45 is going to be a medium height, and I know that this is going to be a small height. So when we multiply these together, we're going to multiply the numerators and the denominators. Root 2 times root 3 is root 6, and 2 times 2 is 4. Then over here we get this. And since we have common denominators, we can combine them. We have root 6 plus root 2 all over 4. Now, we cannot combine root 6 and root 2 because they are not like terms. It is not equal to root 8, so we're going to leave our answer like that. The cosine of 15 degrees is equal to this funky thing here. Cool. All right, let's see. Pretty neat. And I like how, again, the point is I'm showing you practically how I can figure out how to write this formula here without looking ahead and cheating and looking at the notes. So in conclusion for this part of the video, if you zoom back in here and just really think about memorizing these formulas, if we start with sine, or if this is sine over here, then we're going to start with sine here. And then the next one will be different because the signs are the same, but these two trig functions here are not the same. And if we start with cosine here, we're also going to start with cosine here. And this will also be cosine, which is the same because these signs here are not the same. So that was maybe a little bit fast, but I'm going to post this video if you want to watch it again. If you have other ways of memorizing how to remember these formulas, that's totally fine. I'll show one other way, though, that some people write it, which is the sine of A plus or minus B. So we're kind of combining these first two together here, is equal to the sine of A times the cosine of B. And then we're going to use plus or minus again because the plus stays plus and the minus stays minus. So pretty much we're just combining these two. They're very, very similar. The only difference between this top one here and this bottom one here is the plus or minus, which we've drawn down here. So the way that we would combine the two cosine formulas into one is a teeny bit different. We'd have the cosine of A plus or minus B. Now remember, cosine always starts with cosine. And what stays the same is the fact that they're both cosine. So that means these by default would both have to be sine. What doesn't stay the same is the actual sign. So this is a plus or minus. So this one would need to be a minus or plus. You might not be used to seeing it like that, but this is the way we write it. The top signs go together, and then the bottom signs go together here. Okay? So lastly, let me fill in. Angle A is first, so it's going to stay first here and here. And angle B is second, so it's going to stay second here and here. I don't know if anyone likes those, but it works well for some people's brains. And lastly, there's tangents. One quick tip for remembering tangent is we know that tangent is equal to sine over cosine, right? Sine x over cosine x. And remember, for sine, the sign stays the same. So in the numerator, it's a plus sign. And for cosine, the sign is different. So in the denominator, it's different than plus, it's minus. So similarly down here, since the sign stays the same down here, the minus stays the same, but the denominator is different. I don't know if that helps you at all. This is just a little mnemonic and trick that for sine, the sign stays the same, right? Of course, it's for sine, the sign stays the same. So different spelling, same word. It's just a little trick. Hope that helps.